Good morning, everyone. So today I am out a bit. I have to be in some meetings, so I thought I would have you guys actually take some notes and make sure that you submit them. So I'm recording the lesson. I gave you guys a copy of the notes in Google Classroom, so you do have access to that. And what you're going to do is you're going to fill out the note page as I fill it out, um, and then you will submit it for a grade in Google Classroom. So make sure that you watch through the video and that you get that done. If you do it, it's literally just, copying down what I write, but you do actually have to sit through this video to get it all. If you have any questions, I will have tutoring open this afternoon. So please don't hesitate to pop in and ask them, but it should be pretty self-explanatory. We're really working off of things we've already been doing in class, and before we apply that to the quadratics systems that we're going into, we're going to kind of go over some things with the absolute value, which you guys have already been working on and are accustomed to. So we are just literally going to go through this note note sheet. We probably will not hit all of the graphing problems because that would be insane. So let's start with, what is the parent function of an absolute value equation? And by now we should all kind of know this one, which is the y equals the absolute value of x, where nothing is happening on that x. Remember, the parent function is like the most basic function, where we're not doing anything to the outside or inside of it. And the next few problems we're looking at are just describing how those functions compare to the parent function and how they shift. And that was what we went over at the end of last week. And if you remember, if something was happening inside that absolute value, it was happening to the x. And if it was happening on the outside of that absolute value, it was basically happening to the y. So if we look at f of x equals the absolute value of x minus 5, what we're saying is this is a shift right 4, right? It's going at, sorry, right 5. I don't even know where the number 4 came from. It's shifting to the right 5. And if we had the absolute value of x plus 9, this is on the outside, so it's our up and down that's shifting that 9. And so this would shift up 9. 9 what? Units, whatever units that we're referring to, right? Negative, this negative on the outside of that absolute value of x was a reflection across the x-axis. I think I like this green color pen. And this 3 on part D that we have, when it is on the outside, that isn't a reflection, right? This is a vertical stretch. Remember, if it was greater than 1, we had a vertical stretch. If it was less than 1, we had a compression. So in this case, we have a vertical stretch, right, by 3, right? By 3 what? 3 times whatever we had before. And then we also have this -2 on the outside, or this -2 on the outside, and that is going to be a shift down 2 units. Like before, when we had the 3 up here in D, we said that's a vertical stretch. Here it's 1/4, and 1/4 is less than 1. And so this is our vertical compression, right? This means it's gonna grow slower than the actual parent function. The other one means it's gonna get vertical faster. than the parent function. And we called this a shrink, or we called it a compression, right? So we have this vertical compression by 1/4, but on the inside of that absolute value, we have that +6, which is also going to be a shift left 6 units. Last but not least, we have over here on problem F, you can see that we do have a shift. We have a lot going on. We have 3 things going on in this one, right? We have that reflection, right, across the x-axis based on that negative, right? So across x-axis. On the inside, we have that +7, that 7 being added to x. So we have that shift left, right? Remember, a plus inside there means a shift towards the negative direction. And I know that that seems against all logic, but it does work, as we worked out in class last week. Shift left 7 units. And we have this -2 on the outside of all of that. And so now we're talking about the y, that up and down, and it's negative. And this one would be a shift down 2 units. And so that problem in and of itself looks way more complex than it is, as long as you know how to do those little transformations. And you guys have that guide to walk you through those transformations, right, that we made last week, hopefully. Hopefully you all filled it out. Um, my in-person classes I know did, because I made them, but I can't really make you guys at home. But I hope you did, because it's kind of a useful form to have when you're actually doing your assignments. The horizontal and vertical shifts tell you the location of the vertex. And if you remember, when we were talking about the vertex is that turning point that we have. When we're talking in terms of absolute value functions. And we have a vertex too when we're talking about parabolas, but today we are not. I only mention that because that is what we're about to be moving into. So if I have a function, f of x equals a, we don't know what that is, times the absolute value of x minus h plus k, where the vertex would be hk. Now notice I didn't put negative h. It would be the positive version of whatever h is, right? It's h without that negative in front of it. Now if that's plus h, we know that our h is negative. I hope that that makes some sense to you. So h and k, we're saying that hk is the vertex. H would be our x value and k would be our y value of the vertex. And that gives us that point where everything is symmetric on either side of it. What it really helps us do is determine where we start our graph, right? A is the slope on the right side, and negative a would be the slope on the left side. So if we're solving this problem and we're trying to graph these problems, it kind of gives us this indicator of how we want this to work off of the parent function. So the first thing that I can do when I'm looking at problem number 1 is that I can see the vertex right away. My vertex is going to be, this is -2, which means that our h is going to be 2, right? This is our hk. Our h is just 2. Our k is -4. And what that does is it gives us a starting point to pick for graphing these problems, right? If I have a point at x equals 2, -4, 2, 1, 2, 3, 4, I know that this is the point that runs down the center. Everything else is symmetric on either side. So if you remember the last time we made tables, right, where we had the x and y, or the x and f of x, right, where we plugged it in. What I'm doing here is I'm going to make this to -4 my center, and then I can pick points around it, right? I could do 1 and 0 for points that are lower than it. I can do 3 and 4 for points that are higher than it. And we can see how this translates, right? If I plug in 1 to that equation for x, I get the absolute value of -2, which is 2. 2 minus 4 is, this would be -2. Um, if I put in 0, 0 minus 2 is -2, so that's 2. Oh, did I do that wrong? 1, look at that, I'm already messing up. So if I put 1 in here, 1 minus 2 is -1, right? And then 1 minus 4 is -3. This one would be -2. And what I do know is that this is going to be the same on the other side. So this would be -3 and -2. And I know that because it is symmetric, right? So I've already got this center point done. So we're going to start with 0, -2, 1, -3. And then on the other side of it, I can see what that graph is going to look like. So on this one, when we look at the problem for number 2, we can see what our h is right away, right? Our h, by the way, is going to be -5. What our k is, though, we don't have anything there, which means our k is just 0, right? If there's nothing there on the outside of it being added or subtracted, it's just a value of 0. So we have that vertex now, right? Our vertex is at -5, 1, 2, 3, 4, 5, 0. It's right on. It's a terrible looking point, but you can see it. You can't miss it, right? And then we can do our graph again. Now, in some ways, we don't even really need to. Like, we know what those points are doing there, right? Like, if I know my first point off of this would normally be 1, 1, we'd know that it's going to move to the left 5 and times 3. I think it's still easier to make a table, unless you already have all of the points mapped out. I would always just make a table. And what we know about that table is that we have that -5, 0. And so we can pick a few numbers higher. So we can go -4, -3. And here we can go -6, -7. And we can plug in these points, right? You should always have 5 points when you make a graph. If I plug in -4, -4 plus 5 is 1. 3 times 1 is 3. If I plug in -3, minus 3 plus 5 is 2. The absolute value of 2 is 2. So 2 times 3 is 6. And then over on this side, I know that I'm going to have 3, 6 because we have symmetry. So here at -4, I feel like I put that point in the wrong spot. I think this is where the original point goes. I think I miscounted. So here at 4, or -4, I should say, we know we have a point at 1, 2, 3. At -3, we have a point at 6. And then we're going to have the same on the other side of it, right? And this will be our new V. And they're all kind of going to work like this. I'm going to kind of come down here, see what we got going on. On this one, I'm not going to graph it. I'm not going to graph a bunch of these just because, well, why, you get the idea. But I will write out the vertex of each of them. And in this case, we have this +1, which means it's going to be negative, because remember what it's playing off of is a negative. So if it's positive, that means we put in a negative number to get there. Here, let's look at this one. If we look at this problem right here, we've got -6 on the inside, so that is going to be a +6 for our H. We have nothing on the outside, so that would be a 0 for our K. What I'd like to point out is that this is a negative right here. So this is going to be a reflection on the x-axis. We're going to go ahead and graph this one just so that you can kind of see the reflection. What I know about this is it is going to look just like the parent function, except for it's going to be flipped over on the x-axis, and it is going to go to the right 6 spaces, right? How do I know that? Because everything on here tells me, right? This negative out in front, like we talked about last week, is a reflection across the x-axis. So we're just taking that regular parent graph and we're flipping it over that line. And then that -6, I know, means it's going to move to the right 6 spaces. So I'm going to graph this one. And I know that my center point there is going to be at 6, 0. That's my turning point, my vertex. So I'm going to put in points at 4 and 5 and 7. I don't even know if I have 8. 1, 2, 3, 4, 5, 6. I have just enough space. I think they planned that. So if I were to plug 5 in for x, I would have 5 minus 6, but that gives me -1. But the absolute value of that is just 1. But that negative on the outside makes it -1. And then this one would be -2. And this is going to be the same on this side, -1 and -2. And when we go to graph this, we know we have our point at 1, 2, 3, 4, 5, 6, 0. And then we have our other point at 5, -1. We have another point at 4, -2, and this is going to repeat on the opposite side of it, right? And so it's not too hard to graph as long as you know where your vertex is, but it's really important to know where that vertex is so you know where to put the point on the line. I'm not going to do these beyond just actually pointing out the vertex. This says +1, which means our vertex is -1, -1. If we come over here, nothing is going on with that x, right? There's nothing happening inside there. It's just the absolute value of x, which means that it's not shifting left or right. So our h value or our x value is remaining 0. And here we are going to have a positive 7. Um, this one I am not going to mess with because I'm not having you guys do any problems like that, and I do not feel like breaking down piecewise functions right now. And I'm sure you're appreciative. This one I am going to do because we actually didn't go over the absolute inequalities, and I just want to show you how they differ. I'm going to do number 9, but I'll skip number 10 so you guys can do the same, but we'll point out the vertex, but we won't do the graph. So if we look at this problem right here, we see that it is less than or equal to. Work it. If you have a problem like this, if you come across a problem like this, work it like there's an equal sign there for starters. Our vertex is still going to be -4, -6. We can still do a chart now based on that vertex. We could put in our x and our f of x or y values, and we can make that center point because it's our turning point, that -4, -6, and I can plug in 2 points around it and figure out what those are, right? So if I plugged in -3, this would be the absolute value of 1, which is 1. 1 minus 6 is -5. If I plug in -2, I get the absolute value of 2, which is 2 minus 6, which is 4. And again, these are going to repeat on the other side of it because they're symmetric, right? I know both sides are always going to be symmetric. And so when I go to graph this and I have that -4, -6, which is my 1, 2, 3, 4 in the negative, 1, 2, 3, 4, 5, 6. And I put that point in, I know that everything else is going to build around it. At -3, I have a point at 5 here at negative, right? And I know that it's going to work the same way on the other side. And I have this graph. And when I have this graph, what you notice is, well, this looks exactly the same, right? And remember that these graphs kind of go on forever and ever, right? In both directions. Those arrows are going to follow at that pace forever and ever in both directions. But what it also says is that f of x is less than the absolute value of x plus 4 minus 6, which means that, say we extended this arrow, and please don't by any means think this is going to be a very accurate drawing, although that's probably the straightest line I've ever made on this thing. Our f of x is all of the things underneath it. And that's what we mean by inequalities, right? We don't have just like one solution, we have a whole set of solutions. And in this case, in this absolute value case, our solution set would be everything underneath that. And I don't need you to spend a lot of time focusing on that. I just want it to be something that you saw because we didn't really go over it. But really today we're more focused on the vertex part than the inequality part. So like I'll cross off this graph here and we will look at the vertex on this one, which we have that going in the -5 direction, which means that this vertex is going to be 5 and 4. That is all I have for you. I'm not attaching assignment to this because I feel like we already graphed these problems. We were more focused today on the vertex and what that means going into these problems. Make sure that you get these submitted, that you copy them down and that you submit them because well, because I said so. It will help us as we move into quadratics because understanding how to find a vertex of an equation really helps us decide where we focus our our graph, not our draft. But that's all I've got. If you need me for anything, I will be in tutoring today at 2. Um, Beyond that, I hope you have a good day, and I will see you later this week.